This is a truly revolutionary approach. A research team from Sweden has succeeded in converting heat directly into electricity without an intermediate step, with an efficiency comparable to that of modern gas turbines. The machines developed are based on so-called quantum dots and do not require any mechanical components. A thermoelectric nano power plant, how it works exactly, which weaknesses it has and which practical applications could benefit from it. Find out all this and much more now on Click Some Science and Fiction. Welcome. Don't forget to subscribe to the channel to never miss a video again.
1, 2, 3.
Mechanical movements are indispensable for power generation by diesel generators or gas turbines. The combustion of the fuels generates heat and then, via the mechanical movements, the electricity. And even in nuclear power plants, energy generation still works according to the Stone Age principle. Water is brought to the boil with the heat generated, thus driving a steam turbine. The newly developed nanoscale thermal engine, on the other hand, does not require any mechanical components but is based on so-called quantum dots. Specifically, the thermal engine is designed as follows. The research team uses two wires with different temperatures as heat reservoirs. Nanowires of indium phosphide and indium arsenide were built as a small structure in between and serve as quantum dots between the metallic reservoir electrodes. So, it's a kind of filter that only lets electrons with a certain energy pass through. The individual electrons are driven by the temperature difference and migrated over the quantum dot from the warmer electrode to the colder electrode. They did the work and a small current flow was created, which the research team could measure in the form of a voltage. According to the research team, the efficiency of the new nano power plant is comparable to that of modern gas turbines. One of the researchers involved, Heiner Linke, comments, "Our approach shows that heat can be converted directly into electricity with high efficiency without any intermediate steps. So far, however, this is nothing more than a pure basics experiment that cannot be put into practice this way. The temperature difference between the electrode reservoirs was only about 1 degree and the absolute temperatures were close to absolute zero. That's minus 273.15 degrees. Practice-oriented applications are inconceivable in this quasi-deep frozen temperature range. Nevertheless, the research team is optimistic. Because of this basis, maintenance-free nano power plants could soon be developed that could use heated electrons in computer processors or heated electrons in solar cells. The electricity generated could also be used in sensors or quantum circuits, even if the yield is rather small. The energy consumption of server farms, for example, could be significantly reduced and they could be effectively cooled in the processors. How to make a DIY thermoelectric generator that can be used to charge your smartphone? Click here for this video, watch it and see you soon. Stay tuned.